If we want AI to actually be able to move around the level, we first need to provide a navigation mesh that can be used to find the path through the environment. We will do this by placing the NavMesh bounds volume within our level, which will generate this mesh for us. We will then configure the generated mesh so that it is optimized for use by our AI. We will then need to verify that the mesh we have asked for is being generated correctly. To do that, we will use an option in the editor viewport to visualize the mesh before taking a closer look at the options available for automatic mesh generation. We will finish up by exploring how to get tighter control over the mesh itself by using the NavMesh modifier volumes in conjunction with the NavMesh bounds. The first step is to define exactly where we want the mesh to be generated using a NavMesh bounds volume. From the modes panel on the left-hand side, begin typing NavMesh bounds volume into the search box. When it appears, left-click and drag from the mode panel directly into the viewport. This volume defines exactly where we would like the NavMesh system to generate the mesh. It doesn't have to be that accurate in size or shape, but I think we can all agree this particular volume is much too small, so let's make it bigger. We'll begin by repositioning the viewport camera to give us a better view of the level, and then using the Move tool to reposition the volume roughly in the center of the space. Then we'll move over to the Details panel on the right-hand side and scroll down until we see the Brush Settings rollout. In this rollout, change the value of X to 4000, and the value of Y to 4000, and the value of Z to 400. If we reposition the camera once more, we can see that this volume now comfortably covers the entire space. However, what we can't yet see is the navigation mesh itself. In order to do this, we need to activate a show flag from the viewport to show the built paths. We can do this by either pressing P for path on the keyboard, or we can also do this by going to the show menu in the viewport toolbar and selecting navigation. Now that we can actually see the mesh, let's move one of our existing cubes to see it update in real time. I'll reposition the camera closer and select one of our cube meshes and use the Move tool to relocate it. We can see that as I do that, the NavMesh automatically updates. I'll now press Ctrl Z to return that cube mesh back to where it came from. As our current level is rather small, it's not really going to cause any trouble to let it update automatically in this manner. However, if we had a much larger level, we may not want this functionality as it may take a long time to do the update. Luckily, Unreal Engine allows us to control whether or not this update is automatic. As our current level is rather small, allowing the NavMesh to update automatically in this manner isn't going to cause us any problems. However, if we later built a much larger level, we might not want this functionality as each update could take a long time and really disrupt our flow. Luckily, Unreal Engine allows us to decide if we want our NavMesh to be updated automatically or not. We can do this by coming over to Edit, Editor Preferences, Level Editor on the left-hand side and selecting Miscellaneous. In the editing rollout on the right-hand side, deselect Update Navigation automatically, and then close the Editor Preferences window. Now, if we do the same thing as before, use the Move tool to reposition any of these cube meshes, we can see that the NavMesh does not automatically update. I'll do the same to a few more. If we wish to see the navigation mesh updated, we will need to use the Build tool. If we head to the toolbar at the top of the viewport and select the drop-down on the right-hand side, we can select Build Paths from the navigation section. Once that's complete, we can close the message log as we're not concerned about the errors at this stage, and we can see that the NavMesh has updated just like it would with an automatic update. As we will continue to use this smaller level for the rest of the course, we should re-enable the automatic regeneration option. We can do that by once more going to Edit, Editor Preferences, in the Level Editor section, Miscellaneous, and then on the right-hand side, re-enable the Update Navigation Automatically checkbox before closing the Editor Preferences window. Before we continue to the next section, I'd like to highlight an important option that's available to you at this stage. We can actually already adjust some of the properties of the navigation mesh using the Recast NavMesh. This has already been created in the scene when we added the NavMesh bounds volume. If we head to the world outliner on the top right-hand side of the editor and begin typing Recast, we will see that Recast NavMesh is in the level. I'll left-click to select it, and then move down to the Details panel and select the Draw Offset option. The draw offset option can be used to either raise or lower the drawn debug of the navigation mesh itself. Note this doesn't alter the position of the nav mesh itself, just the visual debug. This can be useful to show any navigation data that's obscured by geometry in the level. For example, if I raise the debug considerably over the level, we can actually see there are small NavMesh islands inside these pillars that we've created. But it serves as an example of how we can use the Draw Offset tool to highlight any issues that might be obscured by geometry in our level. I'll return the Draw Offset to its default value of 10. While we still have the navigation debug on screen, let's take a look at another handy feature, the NavMesh modifier volume. So far, all the navigation mesh we've created is binary. That is to say that the AI can either traverse to that location or it cannot. But what if we wanted something a bit more subtle than that? For example, how do we represent a route that was valid but was more difficult or dangerous to cross, and the AI should only use this if no other option exists? This is exactly the sort of thing that a NavMesh modifier volume can be used for. We can find these in the Modes panel. Begin by typing nav modifier volume until it appears, and as before, left-click and drag from the Modes panel directly into the viewport. We can see straight away that by default, this will cut out of our NavMesh, but that's not what we're actually looking for. If we move over to the Details panel on the right-hand side, we can see there is an Area Class drop-down option. If we expand this drop-down, we can see a number of default options, and I suggest you read all of the tooltips. For example, the option I just described could be defined by a NavMesh obstacle. This won't actually remove the navigation mesh, so the AI could still traverse it, but it will know that it's more expensive and will try and use any other route before this one. In this way, we can use the NavMesh modifier volumes to add additional information to an area of the mesh without having to add physical geometry with collision that would simply just block it entirely. However, I think that this is a little bit beyond the introductory course, so I will delete the volume. In this video, we took our first step towards having the AI being able to navigate the level. We created a NavMesh bounds volume and configured the project settings to regenerate the mesh automatically when we made any relevant changes. We then enabled a navigation show flag in the viewport so that we could visualize the mesh and confirm that it was creating the shape that we expected. We finished up by seeing how we can use NavMesh modifier volumes to further refine our generated mesh.